Welcome back, students. Today is session 7 from the chapter of moving charges and magnetism, and this is the Q&A session. And this session is based on what we have studied in the previous sessions from this chapter. Now, this question has been taken from the NCERT book, and it is available in the NCERT book. And the question is: a straight wire of length 1.5 meter and 200 grams carries a current of 2 ampere. It is suspended in midair by a uniform horizontal magnetic field. The magnitude of the magnetic field is. So yeah, these are the four options which has been given, and here we have to ignore the magnitude of the Earth's magnetic field while solving this problem. So now this is a figure which was already provided along with this question. So in this figure we can say that this is a rod in which the current is flowing in this direction, and the this is the magnetic field is this symbol indicates that the magnetic field is directed into the plane. So the direction of the current is like this. The magnetic field is directed into the plane, so it will be like this. Now we know that the magnetic force, as we have studied in the previous sessions, the magnetic force is always perpendicular to the magnetic field and the velocity of the charge which is flowing in that object. So now here this current is flowing because of the flow of the charge. So the magnetic force, because it is always perpendicular to the velocity of the charge and the magnetic field, therefore it will be acting in this direction, in the upward direction, like this. So here I am denoting this magnetic force as FB. Now in the question it is written that this rod is suspended in the midair by a uniform horizontal magnetic field. So this is the rod. The magnetic force is acting in this direction. Now this will be suspended in the midair only when this magnetic force is equal to the weight of the rod. If the weight of the rod is more than the magnetic force, then it would fall down. So it implies that for the rod to remain suspended in midair, FB should be equal to the weight of the rod. So it implies that now FB, it implies that now the magnetic force is given by I, that is the I is the current, L is the length of the this conductor, and B is the magnetic field. So ILB, which will be equal to M into G. So it implies that B will be equal to M into G divided by I into L. So now M is given as 200 grams, so I will be converting this into kg, which will be equal to 0.2 kg. G is 9.8, current is 2 ampere, and the length of this rod is 1.5 meters. So here the value of the B will be equal to, this will be equal to 9.8 into 2, that is equal to 1.16 and 18, 19, 1.96 divided by 3. So this will be equal to 0.65 Tesla. So in this question, the magnitude of this horizontal magnetic field is equal to 0.65 Tesla. So the correct option is A. And so in this question, the most important thing is that we have to first of all find the this magnetic force direction, and after that, since the magnetic force direction is acting in the upward direction, So this rod will remain suspended in the midair only when this magnetic force is equal to the weight of the rod. So using this concept, we get this that is FB, that is the magnetic force, will be equal to mg, and then I have put the formula for this magnetic force, which is equal to I into L into B, which is equal to mg. So we have found the value of the intensity of this magnetic field, which is equal to 0.65 Tesla. So the correct option is A. And here most important thing is that we have ignored the Earth's magnetic field. Okay. So this is how we have to solve this question. And in the next session, that is in the session number 8, I will be coming up with some more questions which will be taken from the NCERT book. And so thank you very much for joining this session, and till then, have a nice day. Bye.